Okay, so let me just get into it real quick without wasting time. The diagram shows the graphs of f of x, which is given as negative x squared minus, plus 2x plus 10. There's a day, so we know that that obviously represents the parabola because it has x squared in. And then we're given the straight line function negative 2x plus k. Okay, we can see that the format is given as a straight line. So we know that G is represented by the straight line, or represents the straight line. Then the first question, they said the graph of f intersects the x-axis at a is negative 2. Okay, so I'm going to do it in a ray so that we know that these values are pertaining to f. The graph of f intersects the x-axis. So they are saying that the x-intercepts are a is negative 2 and 0, and b is 5 and 0. And then it says that the y-axis at C, we don't know the value of C, but we know that that's the y-axis of F. And then it has a turning point at D, okay? And then the graph of G intersects the x-axis at B, which is the x-axis at negative 2 and 0, right, at A. So, at B, which is the same as the B value for, so in other words, this represents a point of intersection as well as an x-intercept, so it represents two things. In other words, that means there's two ways that we can calculate it. And then the y-axis at C as well, so we have 2 points of intersection, and the C is also a y-intercept as well. Then E is a point on G such that DE is parallel to the y-axis. So what are they telling us if they say, DE? D is a point on, E is a point on G such that DE is parallel to the y-axis. They are telling us that these all have the same x value. In other words, that line, any point on the line DE will have the same what? X values. Okay, cool. Now we can get into the questions that we've analyzed the information. Show that k is equal to 10. Where is k? It's on here, on the function of g of x. And they told us that g of x is equal to negative 2x plus k. What do we know? G of x is a straight line, and we know that all straight lines are represented by the equation y is equal to mx plus c, where m stands for gradient and c stands for the y-intercept. So if you have a look at g of x, in g of x, we know that the gradient is equal to negative 2 and the y-intercept is equal to k. So when they ask us to calculate k, they ask us to calculate the y-intercept. How do we calculate a y-intercept? We calculate it by making x equal to 0. Okay, that is all you need to do. Oh, my bad. Okay, so because we have g of x is equal to negative 2x plus k. Now the problem is that we can't make x equal to 0 here because it's just gonna say y is equal to k. That's what it's gonna end up being. It's gonna be g of x equals k, which we already know. Okay, we already know that its coordinate will be k, but now we need to find it. Okay, here's what you're gonna do. We have a equation here that has got 3 unknowns. It has y, it has x, and it has k. Now, don't you agree y and x are on the Cartesian plane, which means that if I can find a point which is on g of x, I can substitute x and y, and I can solve for k. So look at g of x and see if you have any coordinates on g of x. Let's look at g of x then. Okay, start from the top where it's starting, and then we're going to go, okay, do we have C? No, we don't. Do we have E? No, we don't. Let's continue. Can you see that we have B? So if you substitute, sub b, which is, what did they give us? 5 and 0, into g of x, then you're going to be able to solve for k. Okay, right, moving on swiftly. That was 1.1. Write f of x in the form y is equal to a, k. Remember this format here, y is equal to a, x minus p squared plus q. It tells us the P and Q are the coordinates of the turning point. Okay, so the turning point will be the value of P and Q. Okay, so if you can find a way to figure out what P and Q is equal to, you'll be fine. Okay, so look over here. Look at this here. Calculate the value of the turning point. Remember, how do we calculate value of a turning point? It's x is equal to negative b over 2a to find the x value. Then you take that and you substitute it into the y, whatever you get for this. So you're going to substitute negative b over 2a into whatever, let's say, for example, you get 2 over here. Let's just say, for an example, you get 2. You're going to take your 2 value and you're going to substitute it into there, and then you're going to get your y value. So then your turning point will be this and whatever you get here. Okay. Or another option you have is to complete the square. Okay, anyway. 1.3 says write the coordinates of D. But I recommend this for number 1.2. I recommend this. Okay, 1.3 says write the coordinates of D, which is the turning points of F. Okay, you will have already found them in the previous one. Remember, it's your values of P and Q. Determine the values of X for which F is increasing. You know how to do this one. The values of X for which F is increasing. Now that you have the X value of the turning point, look at the graph. It increases and then turns and then decreases. So it'll be increasing before this X value. So if this X value of the turning point is 3, for example, you'll say it's increasing where X is less than 3 because it's increasing here going to the left. Okay, when we start from the left, it's increasing until it reaches the turning point, and then it starts decreasing. Does that make sense? So you're going to say when X is less than 3. That's number 1.4. Okay, calculate the average gradient between points A and D. Now you'll have D. How do we calculate gradients? Gradient is equal to y2 minus y1 over x2 minus x1. Okay, and then if the coordinate for D is equal to 3 over 2, the x coordinate in Jala, so that's kind of a clue, ne? So they're telling us the x coordinate is 3 over 2. Calculate the length of DE. Now, what did I say to you? What did I say? If any 2 points or any points are on the same vertical line, they have the same what? X value. So any point on that vertical line DE that extends down to the x-axis will have the same x value. Now they're asking us to calculate the length of DE. If they ask you to calculate the distance, can you see DE is a distance between the two graphs? The distance between two graphs, you're always going to say top graph minus the bottom graph. It sounds too easy to be true and too simple to be true, but it's the truth. You're going to say the top graph. What's the top graph there between DE? The one on top is is f of x, ne? Can you see? And the one on the bottom is g of x. So you're literally just going to substitute those values in. F of x, they gave us as, I've already moved it now. It's negative x squared plus 3x plus 10 minus g of x is what? It's negative 2x plus whatever you got for k. Okay? Whatever let's say you got 5. Plus 5, okay, as 10, for example. Ne? Now you're going to say negative x squared plus 3x plus 10 plus 2x minus 5, okay? And then you simplify that. Now, what do we know? Okay, because we need a length, we need a value. We have an unknown here, which is x. But is it really unknown? If I go there, if you go back a bit, you'll realize that they said the x value of D is 3 over 2. And we now know that because they are on the same vertical line, D and E, they will all have the same x value. So you can just substitute 3 over 2 into here. You can substitute 3 over 2 into the coordinates. So it'll be negative 3 over 2 squared plus 3 times 3 over 2 plus 10 plus 2 times 3 over 2, etc., minus 5. Okay, whatever you got for k, remember this would have been your k value. Whatever you calculated over here, or after this actually. Okay, then if h of x is f of x plus 2 minus 1, so what are they saying here when they say f of x plus 2? They're saying now you're going to take f of, isn't it f of x was, it was negative x squared plus 3x plus 10. They're saying, okay, so that means f of x plus 2 will be wherever you see an x, you're now going to replace it with x plus 2. So it's going to be negative x plus 2 squared plus 3x plus 2 plus 10. And then at the end, you're going to do what? Minus a 1. Just simplify this. Remember, this is the one thing that everyone likes doing. We don't just... No. James, I've never heard of that in my whole life. But I've seen it done, but you don't do that, ne? We don't do that. This is mathematics. Aibo, but wait. Okay, anyway. My point is that you need to FOIL it out. It's going to be x plus 2, and then obviously you multiply this out and blah, 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 minus 1. Okay, That's the number 1.7. 1.8 is determine the values of k for which f of x plus k will have two distinct real roots. Okay, this is something called the nature of the roots. It needs its own explanation. Okay, this one needs its own explanation.